So I'd like to talk about Play, and specifically about how to set up a Play project from scratch, because that part is not really well documented on the website, and there's a few tips you learn. I've been using Play for 3 years, starting with Play 1, and with Play 2 things have changed quite rapidly. So a few words about this. We're going to start with a new vanilla project. If you have installed Play on your machine, you can go and say play new hello Play, and that will generate a nice project with a lot of files. And we're going to be mainly interested for the next 8 minutes in 2 files. The first one is the build SBT file. It's going to be at the root of the project, and it contains the dependencies and settings and other things that might be useful to set up your project. And the other file is the plugins SBT file, and that's in the project subdirectory, and it contains all the plugins that you can hook into your application. So this is a standard SBT mechanism. It doesn't have anything to do with Play, and you can see here that we're actually declaring the SBT plugin for Play. So it's just a standard SBT project, and we just add this Play thing to make it Play. So the first thing we're going to do is to add Scala Reform. Scala Reform is a code formatting tool. In order to add it, we just add this one line in the plugins SBT file, and then we add this one line, which are the Scala Reform settings in the build SBT file. These are the standard settings. You can customize it if you want. I use them as they are because, yeah, they're quite convenient as such. And what does this do? Well, when you write something that's not very well aligned, it looks a bit poor, let's say. Next time you will compile, it will be nice. And of course you could say, my IntelliJ can do this, or Eclipse can do this, but I find that the rule set that Scala Reform uses is more sound than all these IDE tools, and also if you're in a team that uses different IDEs, you will be able to just have a uniform formatting in the build tool and not in the IDE. Next thing, Scala style.
But you have to run SBT compile so that...
Yeah, or if you run it in continuous mode, it will compile automatically and just reformat.
Yeah, because usually when I develop with the Play application, I don't run SBT at all.
You don't? How do you run it then?
I just play, run.
Yeah, but that's...
Oh, so that...
The Play script is just an alias for SBT something something.
Oh, okay.
So SBT is always the underlying mechanism for Play.
Okay. So Scala Reform reformats my code that I written into the Scala file, so...
Yeah.
Okay.
Yeah. Okay, for Scala Reform, then there's Scala style. You know check style maybe from Java. Scala style is the same thing, but for Scala. So again, here we just add a line to plugins SBT saying, hey, we want Scala style. And we add another line in the build SBT saying, hey, we want these settings. And then we also need to define the Scala style config XML. This is a very simple example. There are more elaborate ones on the website. And this one just checks, is there any line in my project that's longer than 100 characters? And if yes, please warn me about it. And if I do have one, then I get XML as output, which is in the check style. And you can hook that up in your continuous integration server, like Jenkins or another one. And if you really don't want any line that is more than 100 characters, you can even make it an error, and then your project will fail literally. They do that at MongoDB at Tengen. They have this for their Java driver or something. When there is a warning with the formatting or so, the whole build just fails. So they're very strict about that, which is a good thing, I think, because in Scala you can really get creative on syntax and stuff. So here you have a way to enforce some level of, quality and style. Next, the sub-project. So if there's only one thing you want to take away from this quickie is the sub-project part. That's what can make your life a lot more, or it will improve your coding experience as your project grows. When your project starts and you have only a few classes, it's fine, but as soon as your project is bigger, it will get slower. As of SBT 0.13, the incremental compiler is much better, and also takes a lot of advantages of sub-project. So how would a sub-project setup look? You would have a core. In the core you would put your base controllers, your base models, your utility classes, etc. etc. On top of that you will have your modules, and each module will depend on the core. And around that you will have a root project which brings it all together. How do we do this in practice? In the build SBT file, we start defining a little utility method that sets up a play project and adds in our settings from all the tooling we've seen so far. Then we declare the core project and the modules and the root project. So here we see that there is some syntax here. So there's depends on. Depends on in SBT land means class path dependency. Resources, classes, etc. will depend. So for the modules, they depend on the class path of the core, and for the root, it depends on the class path of the module. And the root also uses aggregates. Aggregate stands for aggregate every task, SBT task that I run on this project on the others. So if I run compile on the root project, it will also compile the sub-projects. If I run test on the root project, it will also test the sub-projects. If I run package on the main project, it will package it all together and send it off. So that's what you use this for. So what do we get here? We have this file structure. I'm not sure you can read a lot, but mainly it's a directory tree. You've got the main application, and in the modules directory you've got your core, your module 1 and 2, and then your application conf should go in the core's configuration directory, because if you don't do that, then you can't use your application configuration from your submodules, and it will bite you in the tests. Because if you write a test in module 2 and you have some configuration and you have left your application conf in the root conf directory, it won't work. You will wonder why, and that's why. So always put your application conf in the one core module that's at the bottom of the list. And then since play 2.1 you can now split the routes as well, so do that as well. Just split the routes, and in the main routes you can then include the ones that you define in the modules. That's pretty well documented on the play website. There is one thing that you will face as your project grows and you use sub-projects, which is bug 413, which is it 413? Yes, it's 413. I talked with Josh Surt about it at Devox, and the main problem is that SBT uses Ivy, and Ivy is set up in such a way that for each project, all sub-project, all the dependencies have to be computed again. But if you have snapshot dependencies and you have a couple of resolvers, it will for each sub-project resolve them. And if you're on a poor internet connection, or if you just have 40 modules, like I have in one project, and a few snapshot dependencies, you will go insane because it will take 10 minutes to build your project and you will really hate the whole thing. So what can you do about it? Don't use snapshot dependencies. This is a bad idea anyway. Who wants to use snapshot dependencies? You don't want to be on the bleeding edge. You want to use the safe releases. Or maybe you want to, get something in and convince the library authors of releasing stuff. I've done this a few times with the Salad plugin for MongoDB. But that won't always work.
You send a ticking package over to...
Yeah. The last thing you can do, and what I do now when I work on this one project, is to use a local cache, a proxy, like Squid. On OS X you've got this Squidman, which looks really nice and makes it easy to set up. You use these JVM parameters and you'll be all happy about it. And it will be much, much faster than... And you can then code again from Starbucks and be very happy. We're building web applications usually with Play, otherwise, it's a web framework. So let's look at the tooling on the browser side. James Ward wrote this awesome, simple but awesome plugin for Chrome. So you can get it on the Chrome store, it's for free. So you can just go there and grab it, look for Play framework on the Chrome store. And then when you have it, also add the Play Auto Refresh plugin to your plugins SBT and to your project, just like adding these lines. And what will that do? Well, you will have your one screen with the browser, the other screen with your IDE, and somewhere your console with this thing running, and as soon as you change the code and you save, it will reload if you run it with display tilde run, and boom, your thing will refresh automatically. You haven't even touched it, so it's really cool. It makes your application really nice to develop, and yeah, it's really, you feel empowered. Of course, the JavaScript guys have had that for years and years, but hey, you know, we're catching up. Another thing you will get is these open errors in your IDE. So this part I added to the plugin. It will parse the line where it says there is an error at line 9, and it lets you set up your IDE. So for IntelliJ, for example, I don't know for Eclipse, but for IntelliJ there is this thing that you can send it to, and when you click on the link, it will actually go and open the IDE at the exact line where the error is. That's also pretty cool. Okay, and then last but not least, dependency injection. For the longest time, Play hasn't had dependency injection, but now it has since 2.1 for controllers, and it will have even for plugins soon at some point, if this one pull request that defines it is pulled in. How do you do that? Well, instead of using an object here, like you would always do, just make a class out of your controller. This class, in this example, takes as dependency a greeting, and it will greet you if you're nice. And then the other difference with a normal controller is that you have to add this add sign in the routes file. Very important. If you don't do it, it will blow up. And then the last thing you have to do is to set up how will you instantiate the thing. So what you get from the global settings object that or this mechanism that Play uses to configure more advanced things is you get this get controller instance, which gives you the class and expects an instance in return. So here you could wire in Spring or Juice or whatever, but why bother? I mean, you could just also look up the type and instantiate it yourself and be done with it. And that's it. Any questions? Okay, then, yeah, a question?
Well, it's not basically, it's not a question, but I tried this dependency injection solution, and it turns out that it gets really into problems when you try to create URLs. So I had a hard time to figure out how to do dependency injection with this. To create URLs if you start to put them into packages and stuff like that.
URLs?
Yeah.
Sorry?
Like with the router, like reverse router, the thing.
The reverse routing, you mean? But it's,
Yeah, because when you use dependency injection, you have this add thing in your root file,
yes,
and
it was a bug, yeah, at some
Yeah.
point, but I think they fixed it pretty much now.
well, I'm not sure. I mean, I tried it a few months ago. So.
Yeah, no, I think that, yeah, there was a problem with, yeah, you're right, there was a problem with reverse routing, but they fixed it. I mean, I'm using it daily on a daily basis, so it's pretty much working now. But it took a while for the Play framework to get to the point where you could use dependency injection. But yeah, I think they're pretty much done it now.
In regards to the modules, would you say that it's clever to introduce the modules up front when the project gets started, or would you keep it for refactoring later in the project?
I would always start with the core and one module.
Okay.
And then you can always split. Because if you don't, because that forces you to think, is this really core or is this my module? And if you don't, then you have to do it afterwards, and then when you will do it, you will have oh, I have to put this here. But yeah, so it's painful.
What defines the core?
The core in the context of a Play project, I would say, is any base methods you have or base controllers. So oftentimes you end up having your root controller, and you have all your nice utility functions in there. Your root model classes, users, things that are being used everywhere. Authentication, yeah. All these main concerns, you know. All the dependencies, library dependencies that you will want to use everywhere, you introduce them via core, etc. So,
how do you decide which features go into what module? I mean, do you think of it like, okay, this is this feature and the other feature, or do you think of like layers of the application in terms of cross-cutting concerns? I mean, is it like this is the user part, or this is, I don't know, the projects part?
So you have this MVC approach in play. I would go on a feature basis. Like ideally, I would say I have the one thing with the user that's tricky, right? Authentication, etc. Everyone will want to know about the user, so you need to have some kind of user in the core so that modules can talk to each other. So this is the basis layer. I would put that in the core. But say I have one thing about the vlog part of the application. That's one module. The
Admin.
Twitter part, the admin part, etc., etc. So that's how I would structure it.
So is the core the technical core or the business core?
It's a technical core. Yeah, it's a technical core layer where you set up your core dependencies. And also, I mean, you can also use it and put all the core modules inside. But that depends really on your application. That's the case by case thing.
What you get out from splitting up your application into modules is just a structure for you as a developer. There is no effect on how routing works. There is no.
Well, it helps you structure it and it helps the speed. Because if you leave everything in one thing, it will get slow as hell. And if it's split, then the compiler will know, okay, you touch this, but it's in another module. So, and what you can also do when you have several modules defined in a play project on a command line, you can say, that's an SBT feature, but what you can say is project foo, and then it will switch the context to project foo. And you can even run that as its own application if you set it up correctly. So you can only work on that sub part, on this very small specific part,
Yes.
and it will be much faster. I think that's one of the main advantages, other than, of course,
But what I mean is there is no dependency between modules. For example, in ASP.NET MVC, you have a similar concept which is called areas. And you could say like, okay, this is my user area, and then put all the controllers that have something to do with the user inside of that area, and they would inherit the route from the next level of the area.
No,
So
there is nothing like this. You define modules if you want to you define routes if you want to in a module, but you don't have to. You can also just define them on the top level. Although, yeah, you could, not the other way around, of course. Yeah, that's mainly helps to split things. There is no inheritance or it's just a simple project class type dependency kind of thing.
And the main roots file is then in the core file, and delegates for some URLs to
exactly. There is this syntax.
module 1 and module 2.
There is a syntax that lets you just say include this router. So it lets you just say include this specific router. That's the feature that they introduced in 2.1. Yeah. No more questions? Okay, thank you.